Hey, everybody. Bonus material. If you can do this, if this is a challenge for you, great. If it's a challenge that you can actually end up figuring out, fantastic. That's awesome. If no matter what, I want to expose you to it. So you're all going to try it. Whether or not you figure it out and you feel great with it afterwards, that's a whole different story. So in a typical school year, this would be something I'd expect you to be able to do. You might not be able to do it beautifully, but you all need to be able to do it. This isn't the perfect school year. The high school has given us a pass to not have to worry about this so much. At the same time, they want you to be exposed to it. So I'm going to expose you to it. Your goal is to understand it if you can. If you can't, that was my husband. If you can't, you can't, and that's okay. You're going to see it again in Algebra 2. And when you get it in Algebra 2, hopefully your teacher is compassionate. Okay, so your goal is to still get it right now. Okay, all right. So as you can see, 6 steps. You need to write down 6 steps. You're going to fill up a sheet of paper right now, okay? On your sheet of paper, you're going to be writing some steps down, and you're also going to be following all those steps with a practice problem, okay? We're going to do that side by side so you can see what I'm talking about, because this can get really messy really quickly, and to be able to see how it's being worked on the other side with with an actual problem is really, really helpful. All right, so completing the square. First step with completing the square is to rewrite your equation. So 1, a is equal to 1, which is great. In this situation, a is already equal to 1. But then also get rid of your c term, okay? So step 1, write the equation. So it looks like this: x squared plus bx equals c, all right? That c could be like pretty much you just want the c to be moved to the other side. I mean, technically, you're going to be trying to see opposite of what it is or whatever. So don't like judge my thought process there too much. But essentially, in this equation, we're going to add 15 to both sides. Now, notice when I do this, I'm going to leave a space. I'm going to say x squared plus 14x plus blank is equal to 15. I'm going to write plus blank. I'm going to do that right off the bat. This is my own personal method. It's not necessarily what everybody does, but I do it, and you'll understand why. In step 3, we're adding something to those blanks, okay? Step 2, after we've put it in there, we're going to now embrace the concept of a perfect square trinomial. There's a reason why I love perfect square trinomials so much. Perfect square trinomials allow us to complete the square and have it be super slick and easy. Well, not easy, but slick, okay? Slick, cool. Step 2, you are going to not confuse this with the axis of symmetry, but instead you're going to find what this needs to be the perfect square trinomial. So you're going to find the value b divided by 2 squared. Can you see why it's kind of like the axis of symmetry formula? Axis of symmetry is negative b over 2a. I'm having you say b divided by 2 squared. Do not get them confused. It's super easy to do. Everybody does it every single year, regardless of if I say don't get it confused or not, okay? It happens every single year. So we're going to do that with this. My b in this situation is 14. So I'm going to say 14 divided by 2 squared. 14 divided by 2 is 7. So 7 squared is 49. Great. I have a random number now, hanging out with an equation with blanks. What am I gonna put in those blanks? What do you think? Huh? Do you think you know? I hope you do. All right. So now we are going to complete the square. Okay, so we're completing our perfect square trinomial. Do you see where the complete the square sort of concept is? So we're going to complete the square by putting this value in here and here. Okay, so complete the square by placing b divided by 2. Actually, I'm not going to say place. I'm going to say by adding b divided by 2 squared to both sides of the equation. I say both sides of the equations because equations are a scale. They're a balance, right? So if I add something to one side, I need to add it to the other. So right now, I'm going to now add this 49 to both sides. Cool? Awesome. I've added 49 to both sides. This is fabulous. It looks beautiful. Fabulous. All right, step 4. After we do that, we now need to factor our perfect square trinomial. So we're not just using perfect square trinomials. We're also now going to use the square root method. You can either factor it using bottoms up, if that works for you. If you don't want to use bottoms up, you can use it, or like you can factor it using like that sort of that pattern that we used with perfect square trinomials. So factor the perfect square trinomial. So to put this in perspective, perfect square trinomials are a squared plus 2ab plus b squared, and they factor to a plus b, that whole quantity squared, or they're a squared minus 2ab plus b squared, which factors to a minus b squared. Okay, so it's one of those two. This is an addition here, so I know I'm going to use this method. So that means I need to ask myself, what is the square root of 49? What's the square root of x squared? And I'm going to rewrite this. X plus 7, because 49, the square root of 49 is 7. So that's my b that's here. The square root of x squared is x. So that's my a. So I'm going to write x plus 7 squared is equal to, and now I can add this together. 15 plus 49 is 64. Magically, we get a beautiful square root, or a perfect square number. That doesn't always happen. That's why completing the square can get really messy, is because this isn't always pretty. This number is not always pretty either. If this were like 3 divided by 2 squared ends up giving us 9/4. That's messy, and I totally get it. Deal with it. There's a reason why I have always said embrace the fraction, and it's because of this. Completing the square, you have got to embrace fractions. You have got to embrace the messiness of these numbers and just deal with it. And it's okay. It's the like epitome of fantastic mathematics. All right. Step 5. We're now going to finish this baby up, and we're going to take the square root of both sides. Okay, so we're going to take the square root of both sides. When we do that, if I take the square root of this and the square root of this, I now get x plus 7 squared is no longer, the square root of x plus 7 squared is just x plus 7. Square root of 64 is 8. Cool. I also need to pay attention when I take the square root, it's not just 8, it is plus or minus 8. Okay. Your answers will typically be, you'll typically have 2 answers there. So just keep that in mind. Last but not least, step 6, we need to solve for x. Tell my husband to get a drink of water. All right, we now need to solve for x. I'm going to subtract 7 on both sides. So I get x is equal to positive or negative 8 minus 7, which I need to simplify because both of those numbers are pretty numbers. I can deal with a positive 8 minus 7 and a negative 8 minus 7. I need to deal with those. At the same time, if this were plus or minus the square root of 15, I expect you to keep it plus or minus the square root of 15 and have negative 7 plus or minus the square root of 15. I expect you to leave it like that. If we can do the simplification, we need to. So we're going to rewrite this as x equals 8 minus 7, or x is equal to negative 8 minus 7. So 8 minus 7 is 1. Negative 8 minus 7 is negative 15. So x can equal negative or positive 1 or negative 15. All right? And that, my friends, is completing the square. I love it so much. I love it so much. I know. I really wish I could teach you this in the classroom. We could have so much fun. Either way, that's completing the square. If you haven't finished your notes, pause this video so you can. Finish your notes. finish the example problem. So pause this video, finish your notes, and then go on to the next one so you can see 3 different practice problems, because I'll have 3 different practice problems next. Bye.